so this time if we think about the probability statement that we would want to write, we're really looking for the probability that x, because it's still the number of tails that we're focusing on, is less than or equal to 3. Now from your probability distribution, those more general notes last class, if I had to, I could add up all those probabilities that are at 3 and going back, which means I'd have to add up the probability of 0, 1, 2, and 3. That's my last ditch effort if I can't figure out another way to do this. Or I do have an option on the calculator of using a different program. It's close by to the one we were just using, and it's called Binomial CDF. You still put n, comma, p, comma, r. The trick is in knowing that when you're using something with a less than or equal to in the statement, you use Binomial CDF. Right? Calculator is just going to do what you've told it to do. The calculator does not read your paper and know if what you're actually wanting to type in is an equals versus an inequality. Notice which inequality is there. This is only for when you can get a less than or equal to statement. So sometimes they will ask a greater than question and you have to kind of flip it around.
Yeah, I was going to ask you how to do that.
We'll get to that. I want to do this one first, and then yeah, we'll talk about a less than, or I mean a greater than statement. Notice the formula won't work this time. That's why we're going straight to the calculator, because the formula deals with only equal to. Okay, the formula we wrote down was this formula, again, just a quick reminder, and that's only for when it's equal to. So we really don't have a formula that helps when there's inequalities. Even more important then to understand why you would choose the particular function on the calculator and how to plug it in, because you really don't have, I mean, except for adding up all the probabilities in the inequality, you really don't have any other way to know if you're doing this one right. So let's type this one in. All right, so we go to the same place again. Second bars, which is really our distribution menu. Okay, go with the up or the down arrow until you get to B, Binomial CDF. Okay, be very intentional. I can't tell you how many times students are doing this and they get the wrong answer, and when I come over and look at their calculator, they just accidentally picked the wrong one. Okay, you will get a different answer because the calculator is doing something completely different. Yes?
I did this in a formula. Like, how would you do it?
You would have to add up all the pieces. Like if we wanted less than or equal to 3, you literally have to do probability that x is 0, that x equals 1, that x equals 2, that x equals 3, and then add them up. All right? Same information goes in because we're still, for this problem, doing flip of the coin 8 times, still 0.5 chance that I get tails, and I want 3 or less. That's why I say you have to be so careful because the calculator will spit out a decimal and you may or may not realize if what you've picked is the right function or not, especially early on. So be really intentional. Now again, if yours didn't look like that previous screen, then when you choose Binomial CDF, it should open a parenthesis and it's kind of waiting for you to type in your N, comma, your P, comma, your R. Comma is above the 7. Now if we had time, we would sit here and add up the probability that x equals 0, plus the probability that x equals 1, and 2, and 3, and add them all up, and you'll still get this same number. Again, it's a lot more time consuming to do it that way. But especially if you're trying to check something on a quiz or a test, you at least have options, so you have more than one way to check. Again, let's go 3 significant figures. That's one thing I keep having to mark on some quizzes and tests. So for this one, I would go 0.363, and I wouldn't round, so I would just say 0.363. Now to help you with when they've got greater than statements, think about this. Remember how we talked about how those consecutive numbers kind of split our probabilities in half? If I now know the probability that I am less than or equal to 3, what would the probability be that I'm greater than or equal to 4?
1 minus.
1 minus. So sometimes if they ask a greater than statement, you have to kind of think about it and flip it around to be more of a less than statement so that you have the option to type it in the calculator. So real quickly, I want to emphasize, if you've got equals in your probability statement, you want to use binom PDF. If you've got less than or equal to in your statement, you use binom CDF. Anything else? And you have to find a way to kind of flip it around and make it fit one of those two, because that's how the calculator is programmed.